Okay, so I'm going to make these videos even shorter, 15-minute clips, because the last one was really challenging to send. So I mentioned earlier that we learned that we had two different memory systems single-handedly from one person, and that was Henry Molaison, HM. Now, before this, we thought that we had one memory system and that this was just housed in one place. And I'm not quite sure that they knew where in the brain that this was housed. And I'm going to play this video and then I'll talk about it after it's over. I'm hoping you'll be able to.
HM is a very famous patient who suffered memory.
This wasn't the one I wanted. This one.
You and your team need to get things done. With Monday.com, it's easy, fun, and simple. Just add.
On September 1st, 1953, William Scoville used a hand crank and a cheap drill saw to bore into a young man's skull, cutting away vital pieces of his brain and sucking them out through a metal tube. But this wasn't a scene from a horror film or a gruesome police report. Dr. Scoville was one of the most renowned neurosurgeons of his time, and the young man was Henry Molaison, the famous patient known as HM, whose case provided amazing insights into how our brains work. As a boy, Henry had cracked his skull in an accident and soon began having seizures, blacking out, and losing control of bodily functions. After enduring years of frequent episodes and even dropping out of high school, the desperate young man had turned to Dr. Scoville, a daredevil known for risky surgeries. Partial lobotomies had been used for decades to treat mental patients, based on the notion that mental functions were strictly localized to corresponding brain areas. Having successfully used them to reduce seizures in psychotics, Scoville decided to remove HM's hippocampus, a part of the limbic system that was associated with emotion, but whose function was unknown. At first glance, the operation had succeeded. HM's seizures virtually disappeared, with no change in personality, and his IQ even improved. But there was one problem. His memory was shot. Besides losing most of his memories from the previous decade, HM was unable to form new ones, forgetting what day it was, repeating comments, and even eating multiple meals in a row. When Scoville informed another expert, Brenda Milner, to study HM at his parents' home, where he now spent his days doing odd chores and watching classic movies for the first time, over and over. What she discovered through a series of tests and interviews didn't just contribute greatly to the study of memory, it redefined what memory even meant. One of Milner's findings shed light on the obvious fact that although HM couldn't form new memories, he still retained information long enough from moment to finish a sentence or find the bathroom. When Milner gave him a random number, he managed to remember it for 15 minutes by repeating it to himself constantly. But only 5 minutes later, he forgot the test had even taken place. Neuroscientists had thought of memory as monolithic, all of it essentially the same, and stored throughout the brain. Milner's results were not only the first clue for the now familiar distinction between short-term and long-term memory, but showed that each uses different brain regions. We now know that memory formation involves several steps. After immediate sensory data is temporarily transcribed by neurons in the cortex, it travels to the hippocampus, where special proteins work to strengthen the cortical synaptic connections. If the experience was strong enough, or we recall it periodically in the first few days, the hippocampus then transfers the memory back to the cortex for permanent storage. HM's mind could form the initial impressions, but without a hippocampus to perform this memory consolidation, they eroded like messages scrawled in sand. But this was not the only memory distinction Milner found. In a now famous experiment, she asked HM to trace a third star in the narrow space between the outlines of two concentric ones, while he could only see his paper and pencil through a mirror. Like anyone else performing such an awkward task for the first time, he did horribly. But surprisingly, he improved over repeated trials, even though he had no memory of previous attempts. His unconscious motor centers remembered what the conscious mind had forgotten. What Milner had discovered was that the declarative memory of names, dates, and facts is different from the procedural memory of riding a bicycle or signing your name. And we now know that procedural memory relies more on the basal ganglia and cerebellum, structures that were intact in HM's brain. This distinction between knowing that and knowing how has underpinned all memory research since. HM died at the age of 82 after a mostly peaceful life in a nursing home. Over the years, he had been examined by more than 100 neuroscientists, making his the most studied mind in history. Upon his death, his brain was preserved and scanned before being cut into over 2,000 individual slices and photographed to form a digital map down to the level of individual neurons, all in a live broadcast watched by 400,000 people. Though HM spent most of his life forgetting things, he and his contributions to our understanding of memory will be remembered for generations to come.
So one question I want you to think about is, why is it that HM had trouble remembering things even 5 minutes later? And why was it that he had to repeat to himself certain things so that way he knew what he was doing? So the video mentioned he would repeat, he was able to remember something because he repeated it for 15 minutes. So I want you in an attendance sheet to write your name, write the date either of today or yesterday for class, and tell me what you think is going on memory-wise. So we've talked about the levels of processing quite a bit, but I do want to go over it one more time. Remember that long-term retention means to retain something over time, to keep it over time. And so we want important information to be stored in our long-term memory. We want to have long-term retention of this information. And so to have long-term retention of this information, we need to process things on a deep level. It's not enough to just study and read your notes over. You need to rewrite your notes, quiz yourself, quiz a friend, talk about it, make the information meaningful. So if you look at the top is deep or the deepest type of processing. So we also call this semantic. Semantic means concept or meaning. So this is a deep or semantic type of processing. So an example of that would be making your own examples when you're studying for this exam. Something that's more shallow type of processing would be the phonetics of a word. And the most shallow would be the superficial appearance of a word. How might it look? And so you can see that on the x-axis, when people are processing things or encoding things on a deeper level, that they later recognize words, had better chances of recognizing words as compared to people who studied on a shallow level. So I want you to write the answer to this. Also on your attendance sheet, I will collect them on Tuesday. Which type of processing do you think will lead to better recall? We talked a little bit about effortful processing strategies. I was taxing your working memory. Some of you guys told me that you chunked information, and so I put a list of numbers on the board, and I chunked them for you. I put them in hyphens. So it would have been much different had I not chunked the information for you. It would have been much more difficult to remember. When you chunk information, instead of being several bits, you make it one bit of information, which makes it easier to remember. Because remember, in your working memory, there's a finite level of capacity. Some of you guys made mnemonics, so one of the mnemonics for the names was men, or men's, I think it was. So that's creating songs or acronyms to help you remember important pieces of information. You can make hierarchies or categories. A good example of this is this worksheet that I have for you guys. This always helps me when thinking about long-term memory and the different systems. So this, and looking at and studying long-term memory this way, is a way of categorizing and hierarchically remembering the information, which should help you to remember this information better because it makes it more meaningful. Go back here. Many of you guys did immediate rehearsal when I gave you guys the phone number, so you were repeating it under your breath. But rehearsal isn't just something that's immediate. We can think of this as studying for an exam. So when you study for an exam, you should have distributed practice over time, such that cramming does not work in the long term. It might work in the short term. We've all had an exam where we crammed, and it helped us do well on the exam. But right after the exam, the information is going to go in the trash. And if you're not a psych major, maybe that's okay. But since all of you in the course are psych majors, this is information you're going to need to be successful in your long-term career trajectory. So you guys should be studying your psychology material, especially your stats and your method stuff, with distributed practice over time. So an example of that would be studying 20 minutes every other night, 3 hours before you go to sleep maybe, so that way you can have that long-term memory consolidation occurring over your sleep. For the purposes of this lecture, deep and semantic processing are essentially the same thing, making information meaningful. These are all alluding to the same thing. We really like ourselves overall. And so when we make information relevant to ourselves, it helps us to keep that information in our long-term memory system. I think this is a good place to stop this one.